if we have example 2b, I have the series k going from 3 to infinity of 1 over the square root of 2k minus 5. All right. If I had to take this limit, my limit goes to 0, so I know the divergence test is out. So let's give the old integral test a whirl. You've got 3 criteria: positive, continuous, decreasing. If I'm looking at this being positive, right? First of all, if I have all of these values, I'm going from k is equal to 3 to infinity here. So if I'm looking for k is 3 to infinity, is there any possible way that this can be negative? No. And it's going from 3 because we want to make sure to keep this positive down here so I don't get an I for an imaginary number. So yes, for all, you could even write k is greater than or equal to 3 for here. Is this continuous? Is there any possible way for the values for k is equal to 3 to infinity that I can get a 0 in the denominator? No, but so if I could have 2k minus 5 has to be greater than 0, right? So if I add 5, divide by 2, k is greater than 5 halves. Now, what do you know about this? Is that in my criteria? No, 2.5 is smaller than my criteria, so yes. This is continuous for all k greater than or equal to 3, because 2.5 is smaller. That's where my first opportunity to get that 0, right? So beyond that, we have continuity. Is this decreasing? Well, yeah, the only variable's in the denominator, right? Yes. The denominator grows faster than the numerator. Okay, all 3 criteria have been met. No sweat. Now we integrate. I'm going to go from 3 to infinity of 1 over the square root of 2k minus 5 dk. Now this one I purposefully did not change to x. I left it as k because honestly I don't care. The variable is not going to change anything in this instance. As long as if you leave this in k, you leave this in k, right? It's your differential with respect to that variable. Okay, let's do our limit. The limit as, I don't care what you use, b. If you want to go b here, b goes to infinity from 3 to b. Now, if I have this as 1 over 2k minus 5 to that 1/2 power. All right. You can do a u sub, or you can do this in your head. Honestly, that's up to you, right? But if you do the u sub, because I have a feeling with us doing it like this, that's going to make more sense to you. If I have 2k minus 5, du is equal to 2 du. So I have, oh my, that's a k. So I have a 1/2 du is equal to dk at k is equal to 3, u is equal to 1, because I plug a 3 in here, right? 2 times 3 is 6 minus 5 is 1. At k is equal to b, u is equal to 2b minus 5. Okie doke. Let's integrate. I now have the limit as b approaches infinity going from 1 to 2b minus 5. And I'm going to write this, I'm going to put the 1/2 in front, as u to the negative 1/2 du, because this is power rule, right? This is not natural log. It's not to the first power. This is power rule because I have that exponent. So I have the limit as b approaches infinity here of 1/2. If you add 1 to this, that's going to give you u here to the 1/2, bringing that 2 in front because you multiply by the reciprocal. And that's going from 1 to 2b minus 5. Now the beauty of this is those 2's cancel. Oopsie daisy. Oops. So I just have my limit as b approaches infinity now here of 2b minus 5 to the 1/2 power minus 1 to that 1/2 power. What's happening here? Yeah, that goes to infinity. The first one does, doesn't it? So this is now infinity minus 1, which we still know to be infinity, and my integral diverges. If my integral diverges, then I know this is the same behavior. So whether it converges or diverges, it's just the same behavior. Therefore, the series also diverges by the integral test. All right. So if it diverges, then it also diverges by the integral test. All right. Good. So you have to say if it converges or diverges and then what test it is that you did that. So our integration for this is super easy, right? That's not bad integration. The biggest issue that you have is you have to hit those 3 criteria, and then your integration is actually really pretty easy. It's just same behavior. Okay, last one. Last one. Here's example 2C. I would like to integrate here from 0 to infinity of 1 over k squared plus 4. Can I take this limit? The limit goes to 0, so divergence test is inconclusive. All right. Continuous. Positive. Decreasing. Pardon me, is this continuous? Yeah, continuity happens when you either have a whole or an asymptote, right? There is no way to get a whole or an asymptote with that denominator because I have something squared making it positive, then I'm adding something to it, more positive. Yes. The denominator can never equal 0. Okay, is this positive? Again, yeah. There's no possible way for this one to even go negative. It doesn't matter what the criteria is, right? Always positive down here. And that one's a 1, so it is always positive. Yes. This one is always positive. Is this decreasing? Again with the yes. The denominator grows faster than the numerator. Those 3 criteria have been met. Check. Now I'm going to integrate from 0 to infinity of 1 over k squared plus 4 dk. With this, scoot this up a little bit now. We take our limit as, I don't know, b approaches infinity from 0 to b of 1 over k squared plus 4 dk. Do I need to do a u sub here? No. Good. What is it? Inverse tangent. Great job, guys. So this is straight up inverse tangent here where a is equal to 2. So I'm taking my limit as b approaches infinity. If this is my inverse tangent, then I have to account for that a to be 1 over a, right? Inverse tangent of x over a, which is 2, or k in this instance, sorry. And I am evaluating that from 0 to b. Okay, So I have the limit as b approaches infinity here of 1/2 inverse tangent of b over 2 minus 1/2 inverse tangent of 0. All right. So then I look at my inverse tangent here. The inverse tangent of 0 is 0, right? Because on my unit circle, what angle measurement is going to give me 0? So I know that this goes to 0. All right. So now I just have the inverse tangent. What happens when my limit of inverse tangent approaches infinity? Do you remember what that graph looks like? So if this is my inverse tangent, what happens when inverse tangent approaches infinity? Means it goes on and on and on forever, right? What are you going to get up to? Pi over 2. Do you see that? It doesn't matter. So infinity divided by 2, big whoop, you're still going forever and ever and ever. You're going to hit that asymptote. So this is actually 1/2 times that pi over 2. So my final answer here is pi over 4. Now my question to you is this. Is that the value of my series? Negatory, good buddy, right? This just simply tells us converges. And with the interval test, it's just same behavior. The only thing this pi over 4 tells us is that we converge. So you get the same behavior. Pi over 4 means nothing else. Therefore, the series converges by the integral test. All right, so I want to be very clear. All that pi over 4 does is tells us that it converges. Your integral test simply says same behavior. All right, so we've covered 3. The divergence test is your go-to method with that limit not equaling 0. The p series, you have to have the setup for that p, 1 over k to the p. Then you look at your value of p. If it is greater than 1, then it converges. If it's less than or equal to 1, then it diverges. And your integral test, you have to meet those 3 criteria: continuous, decreasing, positive. Then you do the improper integral to get same behavior. All right, guys.